look at the quality control of the tests that have been assigned. And that may depend on what project you're doing, on your data needs, and you may need to adjust some of the assignments. So this is the area where you can go to do that. We'll start off by looking up a test. So let's type in hemoglobin A1C and search for that. Here's the tests for that, and we've loaded it up into the top right corner here. You can see it's recognized, and now we can look at the accuracy of these assignments to see if we agree with the assignments that have been made. And there are some cases where we may not, some cases where the data is ambiguous, and that's what we can look at here. It takes a second to load. It's pulling all the hemoglobin A1C tests into the same screen, so it's a lot of data, but usually doesn't take more than a few seconds. And it's loading now. When it pops up, what you're going to see is the same screen that the code assigner would see. You can see the original data, and you can see the data that is used to score it. And that's what we see here, the original data at the top, and then at the bottom we have the scoring scheme. So this one has a 100% score. All of the different components of that test match. You can see the count here. These are ordered by count, so the next one is a little bit lower. And you can scroll through here and see if you agree with all the assignments that have been made. You may want to look at the quality from a different point of view. For instance, the consistency of the test over time. And that's what we can use this screen for. What it's going to show us is for each site and for each month, it'll tell us whether this test was present or not. So, for instance, here is Manila, Philippines in December of 2015, and we can see that it's colored red, meaning that this test was present. So that's a good sign. And that's what the overview shows with the pop-up window. Some of them are not there. So for instance, Albany, New York did not report this. Most of the ones that are not colored red here, I believe, are discontinued sites. And you, as the person who uses the data, can go through here and validate to make sure that the data is appearing for all the sites that you would expect it to. You can tell there's a lot of data here. We have a very granular process. It often helps to zoom out to see exactly what tests are there and what aren't. And you can see over a very large number of sites and a very large data range. So here's 2015, where they're more homogeneous. Going back in time, they're a little more sporadic, especially as we get into the beginnings of the CDW here around 2000. So these gives you more insight into the code assignments and areas where it may need to be improved. We can also look at the data in another way. We can look at the frequency of tests over time. So this will show the counts at each site for the date ranges of the data. So for instance, we can look here at the first site, which looks like 358, and it graphs the counts across time, and you can see that it's been increasing as hemoglobin A1C has become more adopted. And we can add as many sites on here as you want to. So let's go ahead and add a few more. There's 402, and we can add site 405. And now you can compare between the different sites the number of tests that are performed in each calendar month. And if you see a date range that just drops out, then that would hint that you don't have all of the tests for that site if you think that this is a common enough test to be reported every month. Some tests are rare and may not be reported, especially for sites that are smaller. Another way to look at the data is to look at the result distribution. So for hemoglobin A1C, typically expect a result around 7, 6.5 maybe. And here is a whole slew of sites graphed based on their distribution. So this is a lot of data here, but if you just highlight over one site, you can see the data associated with that one site. This is the median value at each month of the date range. So Site 402, that's the 50th percentile, and the median value is 6.6. If you want to look at it in smaller increments, you can use this button over here to look at every 5th percentile. So now we're looking at site 402. This is July of 2005, and we can see the entire distribution from the 5th to the 95th in segments of 5 percentiles. So this allows you can switch sites, you can see the data in a very macro or a very micro level, and it's another indicator of how well the code assignments have been mapped in terms of what the actual data presents. Another way to do it is to even get more granular, because a site can have multiple hemoglobin A1C results, and we can limit it to just a single test. If we come in here, which we see all the tests, here's the unique identifier for each test, the LabChem SID and the topography SID, and then the name and the specimen type. And we can select a particular test of interest. I found one that's high enough volume to make an interesting display, and if we click the button here, we can see that the description of the test is now changed to indicate that the test identifier is now in the test that's selected. And the same goes for this. You can look at the same metrics over a single test. So for instance, if you wanted to see the number of tests over time, you can come into here and graph this particular test. So at site 573, for this particular test, this is the range across that distribution. Site 573 may have multiple tests, and you can look at each of them by selecting them and then graphing them with this approach. One more thing that you can do is to export the data, and by going to this page here, you can see this button in the top right corner, which has a variety of different formats. So we can export it as text, and we have the text document, which gives us all the identifiers and the LabChem SIDs and the topography SIDs, as well as the names. We can also export it as an Excel file, and we see the Excel pops up down here. We can also export it as a SQL document.